Today we're going to be talking about the concept of a variable, what it is, how we're going to write it, and how you're allowed to manipulate them. I'm going to start with how I'm going to write it, or what the notation is, and then talk about the mechanics and what you're allowed to do. Because once I have notation, once you can understand what I'm writing down, then we can discuss what it really means, right? But I need the symbols first. So let's focus on those. Bear with me on that if it seems strange, because we are going to talk about what this all means as well. So first things first, I'm going to throw up a symbol which will be my variable. This symbol can be anything you want. The most common is X, because mathematicians are kind of lazy and we just do what's easy. And that's pretty easy, right? Boom. But this could be anything. It could be a triangle, it could be a smiley face, Greek letters, it could be anything you want. X is what you're going to see most of the time, so I'll use X. Now there's things that can be around the X. There could be something here, there could be something here, or there could be something here. And let's go through and see what each of these things are. So first things first, we have what could be in front, which is usually going to be called a coefficient. The coefficient is basically the number that's being multiplied by this variable, which is x in this case. So you could have like 2x, you could have something like ax, and so on. Now, when I just write two things next to each other like this, as long as they're not digits, so for example, if I wrote 24, you're going to assume that's 24, right? I would need to put a dot in here to let you know that I'm multiplying. But in this case, when you have variables, if I just write them next to each other, I would assume that that's 2 times x, and I would assume that this is a times x. So you can put the dot there, but it's often just omitted or not used at all. Now recall what multiplication means is repeated addition. So if you had 4 plus 4 plus 4, well, I added 4 3 times, so that would be 3 times 4, or 12. Likewise, if you see 2x, you could rewrite that as x plus x, because I added x twice. Likewise, for ax, you would have x plus x a times, whatever a is. So we'll come back to more of that, but that's what the coefficient. It's the number that's multiplied in front, or it's how many times you add this variable right here. Now the next thing we have is the subscript. All the subscript is a way for me to label. So for example, if you have a book series or something, you might sometimes the spines of those books would have a 1, a 2, a 3, and so on. Now, they're all books, maybe approximately the same size, but even though they're all books and they're all related, they are distinct. They're different books. So if I had multiple x's, then what I could do is x sub 1, maybe plus x sub 2, maybe minus an x sub 3, however I wanted to set it up, and I could carry on. And so what this means is these are all variables, but they're different variables, and they're probably related in some way. Again, we'll talk more about that later on. But all the subscript is a way for me to keep track of these, to do some file keeping. So I'm going to make sure that it's clear these are distinct. So they're not necessarily the same values, whatever those values are. So think subscript, think file keeping. I'm just keeping a record of my things and keeping track of them. The next thing we have is the exponent, or the power, and that's right up here. And let me write an example. Let's say I had x squared, or maybe x to the a. So a very common mistake is that people mix up 2x with x to the second. And you have to remember what an exponent is. So, for example, if I had 3 squared, that doesn't mean 3 plus 3. That means 3 times 3. So multiplication is a shorthand for a whole bunch of addition. An exponent, or a power, is a shorthand for a whole bunch of multiplication. So let me actually write these examples I've been talking about right over here. If I had 2 times 3, I could write that as 3 plus 3 because I added it twice, and I'd get 6. If I had 3 to the second, I could rewrite that as 3 times 3, which is 9. So they're not the same thing. If I've got a variable, it's the same thing. Notice the 2x I rewrote as x plus x. Well, the x squared I could rewrite as x times x. So keep in mind that that's what the exponent means, is repeated multiplication. And so that's all the notation is. Notice that this variable x, I could put numbers in there. In fact, I was using numbers to explain these things, right? I could put a 4 here. So 2 times 4 would be 4 plus 4. 4 squared would be 4 times 4, and so on. Or times any number a, and that could go in here. The only thing that you wouldn't really do with regular numbers is use the subscript. You wouldn't really say 4 sub 1, 4 sub 2, 4 sub 3. That'd be a little strange. You could, but it'd be odd. But because we don't know what these numbers are, the subscript is very useful. I can keep track if I've got multiple variables all related. So that's the notation. Let's dig a little bit deeper into how you can add, subtract, multiply, and divide variables. And then we'll have enough tools to really dig into what's going on here conceptually. So let's talk about adding and subtracting. So if I want to add and subtract variables, they need to be like terms. Then we need to talk about what that means. So first of all, I've got this example x plus x here. Again, you wouldn't normally see this written, but you could write that as 1 times x plus 1 times x. For now, take my word for it that these are like terms. And so notice I've got one x and another x. If I add them, then I'd have 2 of them. For now, it's perfectly fine to think of literally having like a little fridge magnet x and then another little fridge magnet x. Now I've got 2 of them, right? And now, what if I had different numbers besides 1 in front? What if I had 2 x's and then 3 more x's? Well, 2 plus 3, 5. I now have 5 x's. And I'm putting the dots there for emphasis, but again, none of these dots have to be here. You could just say 2x plus 3x equals 5x. And in fact, that's usually how it will be said. What about subtracting? Well, subtracting is going to be the exact same thing. So if I had 2x minus 3x, well, 2 minus 3, that's negative 1. So that would be negative x, negative 1x. Same thing. Remember, if there's a 1, you don't need to bother writing it. So this would be negative x. Or if I had 3x minus 2x, that would be a positive 1x. Or if I had 7x minus 4x, that would be 3x. Just to give you several examples to get the idea going here. Now, of course, subtraction, what if I had x minus x? Well, 1 minus 1, that's 0. And 0 times anything, including an x, would be 0. You've got none of those. So that's adding and subtracting. Now, I mentioned they have to be like terms. What I mean by that is, say if you had different powers. What if instead of 1 times x plus 1 times x, what if I had 1 times x squared plus 1 times x cubed? Could I just write this as 2 times x to the, wait a minute, which power do I use? So that would be the first problem if I wanted to do that. To understand this, let's look at what if x was, say, 3. And I wanted to say 1 times 3 squared plus 1 times 3 cubed. Well, I can't just say that that's 2 times 3 squared or 3 cubed. I can't say it's 2 times 9. I can't say it's 2 times 3 cubed would be 27. Like, that doesn't work. I'd have to know that 3 squared, that comes out to 9, and then 3 cubed is 27, and then I could add those, and I'd get 36. But there's no way for me to really get there directly from the exponents. And because the whole point of an x is that we don't actually know what that number is, there's nothing more I could do to that in terms of addition. Same if this was subtraction. There's nothing more I could do. I would just have to leave it as x squared plus x cubed because the powers don't match. So like terms means that the powers match for variables. The coefficients don't have to match. Notice we were adding things with different coefficients right up here. So that's fine. 2 plus 3 is 5. But for the exponents, if you're adding and subtracting, they have to match, or you just can't do it. You can't add and subtract. So let me give myself a little room here. And now we're going to talk about multiplying and dividing variables. So let's say I had x times x. Well, I told you over here that x squared, remember exponentiation just means repeated multiplication. So of course you can refer over here and go, oh, well, x times x is going to be x squared. But how do you do that more mechanically? Well, this right here is the same as x to the first times x to the first, which may seem a little strange, but that's just saying that if you had 2, you could write it as 2 to the first. Because if this is repeated multiplication, this just means I multiply 2 by itself. Not at all. I've just got 1, 2. Whereas if I had a 2 here, then I would multiply the 2's together twice. So here's your rule. If you're multiplying exponents, let me make my little label here so keep everything nice and organized. So if we're multiplying, and we'll get into dividing as well, if you multiply these, you add the exponents. So 1 plus 1 would be 2, or x squared, which is what I told you over here. So in general, if I had, say, x squared times x cubed, that would come out to be x to the 2 plus 3 is 5. Notice a very common error is that students will see x squared plus x cubed, and they might think x to the 5th, or maybe 5x, or something like that. And first of all, since that 2x is not true, I have a question mark here. Let's make that definitive. No, doesn't equal that. That's a super common error. So be very careful with that. If you're multiplying variables, you add the exponents, whatever they are. If you're adding variables, you don't manipulate the exponents. The exponents either match and you're able to add them, or they don't match and you can't do anything else with them. So be very, very careful about that. Now, a number example with this is, say I had 2 squared times 2 cubed. First of all, let's go down this way and just do it without using exponents, and then come back and look at what's going on here. Well, 2 squared, that would be 2 times 2, which is 4. 2 cubed, that'd be 2 times 2, which is 4, times 2, which is 8. So that's 4 times 8. Well, what's 4 times 8? That's 32. Cool. Well, if this adding the exponents rule works for variables, it should work for any number. So let's check. 2 squared times 2 cubed. Going off of what I'm telling you here, that should be 2 to the 2 plus 3 is 5. And guess what? If you do 2 times 2 times 2 times 2 times 2, you're going to get 32. So that checks out for numbers as well, which it should, because as we're going to talk about, what a variable is it's any number. Basically, we'll elaborate more. Now, that's for multiplication. Let's talk about division. For subtraction, nothing really changed here. If they're like terms, you just add the coefficients. And if you're subtracting, you just subtract the coefficients. For exponents, it's a little interesting. Now, if I want to divide, let's say I had x to the 5th over x squared. Well, don't write it out the long way like this every time. But what you could do is you could say this is x times x times x times x times x. And down here, that's x times x. Remember, exponent is repeated multiplication. Well, what happens here is that one of these x's crosses out with one of these, and one of these x's crosses out with one of these, and so I just have a 1 on the bottom. And so I've got x times x times x left over. That just comes out to be x cubed. Well, what's a nice little shortcut? This could be x to the 5th minus 2. What's 5 minus 2? 3. And we get that x cubed right there. In general, if you've got division of variables, you subtract the exponents. If you're multiplying them, you add, and if you're dividing, you subtract. Notice how there's that parallel there. Multiplication is like the positive thing, the addition, and division is like the negative thing, the subtraction. Now, of course, what if you have a smaller variable on top? No problem. x squared over x to the 5th. That's still going to be x to the 2 minus 5, which is x to the, well, 2 minus 5, that's negative 3. But what does that mean, to have a negative exponent? Well, if we go back to the way I did it over here, this guy right here would be x times x on top, and then I would have the 5x's on the bottom. Well, one of these crosses out with one of these. One of these crosses out with one of these. And I still have 3 x's left, but they're on the bottom. And so this would be 1 over x cubed. And guess what? That's precisely what a negative exponent means, is 1 over the variable or the number to that exponent. Take a breath. We have covered the notation, how you'll see this written, and we've now covered addition and subtraction and multiplication and division for these. And so now, let's talk about what a variable actually is. We've got all these rules and how you manipulate them, but what's going on? Well, what's going on is that there's one of two things that could be going on. The main thing is that I don't know what x is. And there's two different ways that I could not know what x is. Here's one, like an example of a way that I don't know what x is. Say if I had 2x plus 1 equals 5. Well, here what's going on is I just don't know what x is until I look at this and think about it and I figure out what works. So what x represents here is whatever number makes this true. So here, it's whatever number you could plug in here so that when you do everything on the left, you get 5. And so therefore, this equaling 5 becomes true. And so if you look at that, you might notice that what would work is 2. 2 times 2 would be 4, and then 4 plus 1 would give you 5. So in this case, the variable is not really varying in an active sense. It's not changing, right? If you look at what it means to vary, it means to change. So here, perhaps the term variable could be a little misleading because what it's being used for here is a mystery variable. It's a mystery number. It's I don't know what this is. It's something, put something there that makes this work. I don't know what it is at the moment. You can figure it out, which we just did by looking at it. But that's the easier usage of it. And it's the one where the word variable may seem a little strange. But there is another way in which x is a number you don't know. And here's that other way. Say instead of having something like this, what if I had 2x plus 1 equals y? And I'll put the y over here, just out of convention. Y equals 2x plus 1. So I do have two variables here. Don't freak out. We're going to focus on the x. Here, it's the same idea. Whatever number makes this true. But the thing is that you're not told that y is some specific number. Instead, you're told that y equals whatever this comes out to be given some x. So here, x is actually allowed to vary. It's a changing number. This is a little oversimplifying it, but I could say, just to think about this, that it's whatever you pick. Put any number you want right there. So let's just throw some numbers in there. Like I'm going to have x, and I'll just make a little table here. Let's just throw in some numbers. Let's say I have -2, and -1, and 0, and 1, and 2, and, I don't know, 13. Whoa. Let's just throw numbers in here and see what happens. Well, I could have 2 times -2 plus 1. That's just going to come out to be -4 plus 1 is -3. And that's my y. So notice what's happening is that you're not told what y is. It's just saying, give me some x, let that be y. When you throw x in here, you calculate it, you get some number, that's what y is going to be. Excuse me. And so in this case, x is truly a variable. It's changing. It can be whatever you want it to be. It can also be decimal numbers or weird numbers. I'm just avoiding that because it makes the math harder. Likewise, if I threw in -1, I'd have 2 times -1. Let me actually go ahead and set up all my space here. So here I'd have 2 times -1, which is -2, plus 1 would be -1. Here I'd have 2 times 0, which is 0, plus 1 would be 1. 2 times 1 is 2 plus 1, which would be 3. 2 times 2 is 4, plus 1, which would be 5. And then I picked some silly number, 13. 2 times 13 is 26, plus 1 is 27. And so you see how I can pick any number I want, right? I wasn't too adventurous with my number choices here, but you could have been. You could just pick totally random numbers from nowhere and throw them in there, and then you'll get y values out of it. So in this case, this is where x is truly a variable. So you want to work on really separating that in your mind. There's this case where there's just an x and everything else is a number. In that case, x isn't really a variable per se by the way that the word, like what it means. It's just a number you don't know. It's one number that you have to figure out what it is. And when you put it there, it makes that work. In something like this, x is varying. It's any number you want. Just throw a number in there and calculate it. Now, of course, in questions, you'll be given certain restrictions. You could be asked like, ooh, what must x be if y is something? You know, which is like this. What if y is 5? Well, then x has got to be 2, right? But if you're not told some restriction, x is just some number, and you plug it in and it varies. So this just allows you to have a formula, right? You give me numbers, I calculate it, and I give you some other number. And so I always know what to do. So make sure you have that distinction very clear. One final thing I want to point out is that you may have noticed over here that I used ax, and x to the a. And you may be thinking, ooh, isn't a variable? Well, of course, I mentioned that these are symbols, right? And you can use whatever symbols you want. But by convention, when we use something like A, B, C, letters from the beginning of the alphabet, those are just numbers we don't know, or that don't matter. They're just some constant number, but they're definitely not variables. They're a number. I just don't know what that number is, or I don't care what that number is. Whereas when we use X, Y, Z, things towards the end of the alphabet, by convention, these are varying numbers. Again, by convention, right? And I could have this where 2x plus 1 equals 5, and x is some specific number. But in general, when you start off, when something's set up, if I've just got something that's always one particular number, but I don't know what it is, you'll see the beginning of the alphabet used. And if you've got something that can change and vary, it could be whatever you want, like over here, it'll usually be letters towards the end. So that's been a general overview of the notation and the properties and rules for variables, how they'll be written, what you need to be careful of. And finally, talking about what it means, like why do we need variables? Couldn't we just do numbers all the time? Well, the thing is that instead of having to sit down and come up with 2 times 3 plus 1, and 2 times 5 plus 1, and 2 times 4 plus 1, and 2 times 100 plus 1, and just write down like every single way to do that, I can just say, look, I want 2 times any number plus 1. So this just, it allows you to save time, and it allows you to model things that change, right? So that's been a general overview of variables.